let's change gears entirely and forget about VMware, not entirely, but move on to the concept of microvisors. So let's start off by talking about what there are for infrastructure options. So when you're actually trying to go off and build an app, you have all sorts of different options on different approaches to do it. And let's start off by dispelling the idea that there ever is such a thing as a full stack developer. I believe that anybody who calls themselves a full stack developer understands these little tiny portion of the stack that they use and doesn't even realize that more stack exists on either side of them. So it's the concept that there's a full stack developer is complete fantasy. But there are all these various different options, and if you're a developer, you probably have an idea of where your expertise is and what your goal is, and you probably have a pretty good idea of which of these pieces you're going to put together. But from the outside, if you're not a developer, these might sound like a bunch of disparate ideas that don't really, how do I do this and with this, and how do I put them together and make something into a development system that's actually usable? Well, the point is that these are not really independent ideas. Let's first off get off the idea that there's something like serverless. Serverless is software as a service through an API. And in fact, I actually got told that some people are starting to call it function as a service, which is a little bit better named than serverless. So there is no such thing as serverless. I'm going to use serverless and software as a service interchangeably here because they're the same thing. You would actually run this on top of, you have software as a service through containers. So containers are actually where the code lives to allow this stuff to work. And this typically gets layered on top of virtual machines, and virtual machines live in hypervisors, and there's pieces in bare metal. So this actually shows you the stack. So with bare metal, if you start at the bottom, bare metal basically is lots of different flavors. It takes lots of time to manage. It takes lots of time to actually do all the connections, all the hookup that you need to do to make this work. And so typically you want to abstract this a little bit and try to do some isolation, protection, security at the hypervisor layer. So you actually have some way to divvy up this hardware in a reasonably secure way and a reasonably dependable way. So like I mentioned, the vMotion from VMware gives you the dependability that you're after. And the virtual machines actually give you a runtime environment. They can give you a variety of runtime environments that you can do. So depending on what your application is, what your use case is, you're going to be using an entirely different runtime environment for a database versus a desktop. You're going to be using an entirely different runtime environment if you're like running a control system for a manufacturing plant versus a web server. Containers were actually just a way to try to isolate the runtime environment. So people would put together programs and it would run great on one virtual machine, and they try to transport it to another virtual machine, and the libraries would not be quite the same. There would be all sorts of various things that didn't quite work right because the runtime environment was wrong. So containers were simply an idea of, hey, let's not just package up the app, let's actually package the entire runtime environment into this thing as well and have it all as a single piece that can get moved around. And oh, by the way, this thing can actually get moved into the cloud. I don't actually need to be running it on my desktop or in my data center or anything like that. And if you do the right type of container, it can actually be run in different types of clouds. So you're not even tied to a particular cloud. You can actually build this thing out, have an entire runtime environment, and there's nothing else that you really need to work with it. And the serverless or software as a service is kind of how you would use this. So there's serverless or software as a service. There's nothing there. It's a matter of the top edge of your container. This is how you consume what's in your container. So looking at it a different way, like a good example would be facial recognition, which we'll be talking about a little bit more later on. So if you have like a facial recognition setup, you would have an API call that you would call into with your serverless or SAS, and the container would actually contain the code that ran this facial recognition stuff. And the virtual machine, Linux, let's just call it Linux in this case, is going to be the operating system that this container runs in. The container is going to have its own runtime environment, but Linux is going to be there to handle things like how do you do persistent storage, how do you hook up to the network, how do you manage the memory, how do you schedule various different processes. The container doesn't do any of that itself. It counts on the operating system to do that. The problem with the operating system is that the operating system wants to run in privileged space some of the time, and the only way that you can actually divvy up that privileged space is you need to put it on top of a hypervisor. If you have a bunch of different things running on one operating system, they all have the possibility to go in and interfere with each other or hurt each other by running in privileged processor mode and causing damage. So that's why you have the hypervisor, the microvisor, and the bare metal is what runs this entire thing. Regardless of how you slice it, end of the day, serverless, SAS, whatever you want to call it, there's something running that somewhere. And I guess one of the things to think about is that if you look at it from various different approaches, I mean, you could have the idea that you can have a cloud application, and the only thing you care about are the serverless as a service and the containers. You build your container, you consume the APIs that are on top of it, and there actually are customers out there. There are not customers, but consumers out there who will only care about this. They're not terribly common. Lots of times you'll at least have something. You'll at least have a laptop that you work on, so you have to do something. You have to have some understanding of something below the container level. And then there's the hybrid cloud model, and this is what everybody's talking about today. Hybrid multi-cloud, I believe, is the slogan of about 15 different companies right now. And the whole idea with hybrid is that you actually cover everything from roughly the virtual machine layer up to containers, and the ability to actually have those containers run off in some public cloud as well as in your local cloud. In this case, you really don't care about the bare metal much anymore. The bare metal has almost become commodity. You buy something off the internet, you rack it up in your data center, and you go. So there's not really this concern about what actually is the bare metal. You just worry about what you need to run on top of it to make it work. And so, there actually are bare metal operations. So lots of times, like things like embedded systems or things where you actually do have to do a lot of fine-grained control. You actually need to be able to understand how the hardware works and how it's going to interface with your mechanical surroundings to be able to do this. So there's, that's typically where you end up with the on-premises setup. And yes, you'll undoubtedly have hypervisors that run on top of this and some software that runs on top of that, simply because you need to be able to simulate things. You need to be able to test out the various different pieces. But this is often the breakdown of where you get things. And each one of these entities might think that they're a full stack developer simply because that's the only portion of the stack they really understand or care about. Any questions so far? I'm getting looks like you're following me, so if you have questions, jump in, because I'm doing this for your benefit, not for mine. So let's since I told you I was going to talk about microvisors, let's actually talk about microvisors for a little bit. So with a hypervisor, you end up with a kind of heavyweight, well-defined, isolated way to actually run an environment. With the containers, you end up with a very lightweight, very fast, responsive way to actually run an application. So if you're actually a developer or somebody putting together requirements, you typically say that I want a multi-tenant system that's fast, responsive, secure, dependable, and scalable. And so you try to put all those things together. That you're not going to get that from a hypervisor, because the hypervisor is going to be kind of the low end of this, the heavyweight portion of this. It's not going to be the fast, responsive, or necessarily scalable. There's always costs associated with the hypervisor. You have to license them, and even if you don't have to license them, they're typically not terribly easy to maintain or manage. The containers would give you the fast, responsive, and scalable, because the container itself isn't really scalable. The way you scale containers is you just deploy more of them. You just deploy as many as you need to make things happen. The microvisor was kind of the way to take the center line between these. So you need something that's isolated, you need something that's secure, you need something that's dependable. So the microvisor is going to be able to run an OS, just like a hypervisor is going to be able to, but they've typically been stripped down, so they actually boot up fairly quickly. They're scalable because you can run more than one of them. They're intended to be free, kind of like a puppy is free, in that you have to maintain them yourself. But they have a fast enough boot time, and the whole idea is, some of the microvisors, they don't even have any state associated with them at all. All of the state comes from the container that they're. So you power on the microvisor and it runs a container, and when you're done, you kill it. And if you want to run that container again, you power on the microvisor again, and it doesn't have any memory of the last time it was powered on. It just knows that it needs to run a container. The container might actually have stateful storage behind it that it writes to or reads from, but the microvisor itself won't. So it's how do we actually do microvisors? Well, it's still a VM with its own OS, and that OS is almost always Linux. It doesn't have to do things like support floppies. It doesn't have to support IDE drives. It doesn't have to support like the persistent memory that I talked about VMware supporting. It doesn't have to support any of this additional crap. It doesn't have to have virtual stereo ports. They might only have one Ethernet adapter, one Ethernet setup. They don't typically have a BIOS that needs to boot up. It's typically just starting a program as well, but it still runs as an isolated box. That's the joy of the new processors that are out, where you can actually say that I need to run this in its own environment that's protected. And it typically will only support Linux as its OS. So it will typically be something that's normally like a Linux kernel running something that says I can run another version of Linux on top of me. So that's where we are with microvisors, and that's another way that you can actually use your data center. So if you don't want to go the route of building out a complete vSphere infrastructure and having vCenters running around all over the place, if you just want to have an environment where you're trying to run an application upon application, you can probably do that with microvisors and still make reasonably efficient use of your hardware. At the same time, you're not necessarily going to be able to manage it as well. You're not going to be able to use the interesting aspects of your data center as well. You're not going to be able to use all the interesting networking capabilities. You're not going to end up with the idea of storage vMotion. That's one of the things containers don't address at all. The whole idea that there's no way to have continuity with a container and a microvisor. Either it's up and running or it's not, and if it dies, that's when you try to restart it. There's no way that you can say, okay, this piece of hardware is going down, I need this microvisor to move this to some other chunk of hardware and have it running continuously. So, I mean, that's kind of where I see microvisors fitting into the enhanced data center workloads these days. It's a different way of handling the applications rather than having your very rigid virtualized infrastructure that we currently have.
Are there any particular brand names of microvisors or particular vendors who are producing them, or is it just grab your own and away you go?
OKD is the one that I've heard of.
Okay.
I don't know a whole lot about all of the various different types of microvisors. I'll freely admit that I got most of this material from having long discussions with Adam Carter.
Okay.
So Adam Carter is the person in our organization who looks an awful lot into containers, and we had started having a microvisor discussion about a month ago, and it's like, this is probably something that would be suitable for Tech Field Day. Let's go with it.
Yep.
So I have not actually done a whole lot with microvisors, largely because I'm a storage janitor who's a VMware bigot.